Now, what does it mean to factorize? I want you to have it in mind that when you are factorizing an algebraic expression or any other kind of factorization, what it simply means is showing how we multiply two or more terms to generate the actual term that make up an algebraic expression. When factorization is involved in algebra, many methods come to mind, so we'll take them in stages. In our current class, we'll be discussing factorization by using HCF, highest common factors. After that, we'll deal with factorization by grouping. Do well to see the video. And after that, we'll look at some other kinds of factorization that occurs when algebra is involved, depending on the kind of algebraic expression you are dealing with. So at the moment, let's swing into action. We are going to be working using highest common factors. Follow me. For the first case, this is 6y plus 30y. You can easily say, since they are like terms, just add them. 6y plus 30y is 36y. You are very correct. But this is placed here because I want to show you something important. It's 36y. Yeah, but let me show you how to do that using factorization method. So as it suggests working with HCF, I will begin by considering the common factors of 6y and 30y. Obviously, you know that by HCF, 6y is exactly the same as, I can write it as 2 times 3 times y, isn't that? And 30y, on the other hand, will be the same as 2 times 3, which is 6, times 5, which is 30, times y. By HCF, what's common? 2 and 2 common, I'll bring it down. 2 times 3 and 3 common, I'll bring it down. 3 times y and y common, I bring it down. Y. And that gives us that the HCF of what we have here, HCF of 6y and 30y is 2 times 3, 6 times y, 6y. This is the HCF. Now let me show you how you factorize using HCF. Since I already know that 6y is the highest common factor of 6y and 30y, watch the way I'm going to demonstrate that using factorization method. So 6y add 30y. What will it become? HCF is 6y, so I factor out the HCF. I keep it right outside and open a bracket. By how many places will 6y multiply something to give me 6y? It's just one place because 6y multiplies 1 will give me 6y. Okay, then by what number will 6y be multiplied to give me 30y? The number is 5. Did you notice it is getting simpler, but this time with a bracket? Simplifying the bracket, 6y comes down, and then 1 plus 5 is 6. It's time to multiply. 6y times 6 will give us 36y. Can you see that we have just arrived at exactly the same answer you gave us from the beginning of this problem? What I have just demonstrated is an easy way to show how to factorize an expression. Did you see that? So it matters a lot to know the highest common factor of the terms you are dealing with, because that will enable your factorization to go smoothly. As we work out these other problems, we'll be applying similar skill. The only thing I might be skipping for the sake of time is the process of solving the HCF. You already knew that. You began learning that from primary school actually. So let's swing into action and work it out. So the next problem we have right here on the board is pi radius squared add 2 pi r times h, that's times height. Okay, so bringing it out and examining properly to find the HCF, pi radius squared plus 2 pi radius times height. First, I know what's common between pi, and that thing is pi, because pi and pi have pi with them. This is radius squared, but here I have just one radius. So what that implies is that the highest common factor of radius squared and radius itself is just radius itself. There is nothing else common because we have height on the right hand side, but on the left we don't have height. So this is the HCF we are working with. Once you get the HCF, open a bracket. and bring in the remaining terms. So pi r multiplies what will give us pi r squared. Pi r times r is pi r squared. We're done with the first side. The next, pi r multiplies c. Pi r can cancel out pi r, so you're just left with 2h. It means that pi r multiplies 2h to give you 2 pi r of h. We have ended up simplifying this also. Did you see? That's how you factorize. It's as easy as that. Sometimes it doesn't take 1 minute to work out a problem when you are dealing with factorization. But depending on the complexity of the problem, remember your highest common factor in your mind all the time. Let's take a look at the next case. C, a cubed open bracket b minus 2c plus a squared open bracket b minus 2c. There are so many common factors looking at the first term and the second term. So what would you do? How would you find it? Do we need to open up the brackets first before we can find them? Not necessarily. Take a look at this. This is a cubed. This is a squared. I can first take their highest common factor. And the highest common factor between a cubed and a squared is a squared. That is the highest common factor I get there. There are more. See, in a bracket I have b minus 2c. Yet in the second bracket I have b minus 2c as well. So I can bring it down as part of the common factors, b minus 2c. Now that I've reached this level, it's time, because I have already taken the highest common factors as a squared open bracket b minus 2c. So what will they be multiplying? A squared open bracket b minus 2c can only multiply a to give us a cubed b minus 2c. So a goes into that bracket. Plus, watch, the highest common factor is exactly the same as the second term. So the only thing it can multiply to give us back itself is 1. This becomes our factorized version of the question above. Did you see how easy it is? I know that you can do it, and that's why I'm showing you this in stages. Try out question D. Let's see what your answer will be. Pause this video, give it a try, and let's compare. Now, did you get the answer right? Because we're about to solve it together. Alright, the question is negative 4 open bracket a minus 2b close the bracket squared, add 8 open a bracket a minus 2b. The first thing to do is to find the HCF, the highest common factor. Alright, so to do that, we look at it critically. The very visible highest common factor we can see here is that of a minus 2b squared and a minus 2b. The common thing between both of them is a minus 2b. I'll just keep it down. But that's not all. Take a look here. For the constants, between 4 and 8, the highest common factor is what? It's 4. 4 can divide both numbers. I'll just bring it out here. This altogether here is what the highest common factor will be. Therefore, it is with 4 open bracket a minus 2b that we will simplify what we have up there. So to do that, we'll go ahead straight away by working it out. So 4 open bracket a minus 2b will be multiplying the variables remaining. First, we have negative 4 here. So what do we need? It's going to be negative 1. Here we have a minus 2b. But here we have a minus 2b squared. So by what will a minus 2b be multiplied to give us a minus 2b squared? It's by itself. But because of this negative sign, it's not just going to be by itself, it's going to be negative itself. So it's going to be negative itself, open bracket, a minus 2b. That is what it is. Now add, we already have 4 outside. 4 can only multiply 2 to give you 8. But what about a minus 2b? A minus 2b is outside, already factored out. To multiply itself, it just has to multiply 2 and then an invisible 1 behind the 2. So 2 times 4 is 8 and a minus 2b times an invisible 1 is a minus 2b. Hence, we'll leave it this way. You may choose to simplify the bracket. It works, so let us do that. Outside the bracket, we have 4 open bracket a minus 2b, close the bracket. But inside the bracket, we can open it up. And to do that, it's easy, yeah? We open the bracket now. Negative multiplies negative will give me positive. So the 2b is positive 2b minus a This is part of the bracket, so you can keep it with them, plus 2. It is what it is. We cannot go further with that because we have already simplified. This is the end product of factorizing the question in D. Let's try some other example. Now this is example E, and inside we are supposed to solve 2 open bracket r plus s, close the bracket, open another one 3t minus u, close the bracket, plus 3 open a bracket r plus s again, close the bracket, open another one 2u minus 3t. We are required to also factorize this completely. Don't forget your skill of highest common factor. It's going to help us here. Merely looking at the question will reveal the highest common factor to you. Have you seen that? Take a look at this. Did you notice that we have r plus x in one bracket and we also have the same r plus s in another bracket? That is going to be a factor already. Do we have more? Well, let us see. Therefore, to begin solving a problem of this nature, I will take out the highest common factor, which is r plus s, like this. R plus s is my highest common factor so far. Therefore, I'll be multiplying it with the other variables in the bracket. First, to get 2 into r plus s simply has to do with bringing in 2 here. So 2, open another bracket, 3t minus u. We have taken care of the left hand side already. Plus, bring in your plus. 3 is out there, bring it in, and then we can't multiply anymore to get rs because there's an invisible one already waiting for us here. So what comes down is 2u minus 3t. Now what we are going to do is to open up the brackets inside. Perhaps we can find some more. So let's see. R plus s comes down, as we already have it out here. Let's try working out with this bracket. So what do we have here? 2 times t, 2 times 3t gives us 6t minus 2 times u is 2u. Plus 3 times 2u is 6u. And 3 times negative 3t will give us negative 90. Could there be something inside that we can also factorize again? Let's watch. First, r plus s, open bracket, 60 minus 90 will give us negative 3t. So negative 3t we've got here. And negative tu, negative 2u, add 6u will give us positive 4u. So do you see anything common with both of them? Nothing is common. So it simply means that we are leaving our factorized version as r plus s, open bracket, 4u minus 3t. This is great. We are done doing that. It is simplified already. It is factorized already. What this implies is that all that we have up here is further factorized into this small expression that you have down here. This is how it works when you apply the highest common factor method during a factorization problem. Let's go further into factorizing by grouping and see how that works.